Now we shift our focus to organic rich source rocks, which we loosely refer to as shale gas, shale oil reservoirs. So the term organic rich source rocks actually refers to hydrocarbon bearing source rocks, and these could include shales, mudstones, siltstones, and carbonates. So even though we loosely refer to them as shale gas, shale oil reservoirs, the oil could actually be in low matrix permeability mudstones, siltstones, and carbonates. The matrix permeability is extremely low, so we like to use the term ultra low just to indicate it's actually lower than you would have in, say, tight gas. It's typically lower than 1,000 nanodarcy, which is 1 microdarcy. So it's lower than that. So that means the permeability is in the nanodarcy scale. The porosity is very low, typically between 3 and 9%. The matrix is typically fine grained, so the sizes of the grains in the rock are very small, and that's why the pore spaces are also very small. It's typically laminated and naturally fractured. So you have natural fractures at multiple scales in these organic rich source rocks or shale oil and gas reservoirs. You have varying total organic carbon content. Some can be as high as 12%, and then we've also seen some as low as 1%. And these are some of the shale oil and gas reservoirs we have produced. So that range is typically between 1% and 12%. And the amount of the total organic carbon content actually influences the storage. Why? Because when you have higher TOCs, then there is more potential to have gas stored in the sorbed state, adsorbed on the walls of these organic matter, basically. Also, as TOC increases, the rock actually gets weaker. So at fairly low TOCs, like you have in most of the commercially produced shales, most of the rock is inorganic material, which is typically stiff. But if the TOC were to increase beyond, say, 30%, 40%, and you have considerable amount of organic matter which is weak in comparison to the stiff inorganic material, then the overall stiffness of the rock actually reduces. They are generally brittle, which is related to these TOC. When you have low TOCs, typically less than 12 like we have in most of the commercially produced shales, the rock is usually brittle. And that is why it's easy to fracture them. And that is key to producing these shale resource commercially. So the brittleness typically comes from the quartz and calcite. The ductility you could have if you have high TOCs and if you have high amount of clay. So clay materials and the kerogen, which is the organic matter, those are the fairly ductile materials. They are weak compared to the rest of the material in the rock. Shale is also fissile, and that refers to its tendency to split easily along its plane. So in the class, I'm going to show you some shale cores, and you will see some of them have actually been cracked just because we basically subjected it to low pressures. So the rock can be intact in the subsurface, but just bringing it from the subsurface to the surface, it can actually break along the bedding planes, because now the force that used to keep the rock together has been reduced or basically taken out when you bring it to the surface. And that ability of the rock to break, or that tendency of the rock to break easily along the bedding planes, is referred to as facility. So why develop unconventional oil and gas reservoirs? Unconventional oil and gas reservoirs is just another term for shale oil and shale gas reservoirs. To answer the question of the importance of developing unconventional oil and gas reservoirs, let's answer a couple questions. One, what was the contribution of tight oil or shale oil to total US oil production in 2021? Remember, a year before that, which was 2020, crude oil futures became negative for the first time. And so you will have thought the contribution of tight oil and shale oil to total US oil production in 2020 would have been impacted, right? Well, it was 65.8% in 2020. In 2021, it was 65%. So basically, little or no change. It's still very significant. Most of the oil produced in the US is still coming from shale oil. So it's important to develop shale oil or tight oil reservoirs. And this is the plot from EIA. I'll give you the link shortly. This is millions of barrels per day. Historical production to the left of this vertical line, and the rest is the best case forecast. So you can see the contribution of tight oil, which is same as shale oil, in comparison to the conventionals, mostly coming from the Gulf of Mexico and other conventional reservoirs. Same question, but for gas. What was the contribution of shale gas to the total U.S. natural gas production in 2021? Even more, 79%. The year before that, in 2020, it was 78%. So shale gas is still contributing most of the natural gas production in the U.S. That's why it's important, and that's why we're talking about it. This is the plot coming from EIA. This is the source. You can click on it. When you get there, you want to look for the all charts PowerPoint file, and you will see several plots, and I only show a few of them here. And here we're looking at trillions of cubic feet per year, and you can see the green is the tight oil, accounting for most of the natural gas produced in the US. These are some plots I'm not going to talk much about. They are self-explanatory. We are just breaking down the shale oil into the different shale plays that contribute these different varying amounts. And later we're going to summarize that the Wolfcamp, the Bakken, that's the red, and this yellow, which is others, contribute most of the shale oil. Again, this is self-explanatory, also coming from the same source I gave earlier. This also comes from the same source, but this is for dry gas, shale gas basically. And we're showing the different contributions from these different shale plays. The Marcellus shale play contributes majority. Also, you have significant contribution from the Haynesville and the blue, which is the Utica shale gas plays. And like I said, this is the source of the data. In summary, developing shale oil and gas reservoirs has helped the U.S. meet our energy demands. Before we were able to produce shale oil and gas commercially, there was the concern that the demand for energy was going to exceed supply. But with the development of shale oil and gas production over the last 15 years, we've seen way more production or supply than expected before these resources were commercially developed. The contribution of shale oil and gas to total oil and gas production in the U.S. has grown significantly over the last decade. Most of the tight oil or shale oil production is from the Wolfcamp, Eagle Ford, and Bakken shales, like I mentioned, where we were looking at the last two slides. And same deal for shale gas. It's come from Marcellus, Ainsville, and Utica, also from the last two slides.